So in this video, we're going to discuss what can affect the E naught of a cell. What can affect the electromotive force, another term that we have learned recently, abbreviated EMF. Can we increase it? Can we decrease it? What are some things that we can do to change the voltage? So let's say we have this cell set up. We have solid zinc reacting with copper chloride to make zinc chloride and solid copper. So first thing we need to figure out, just for a review, is what is the voltage? Well, here are the standard reduction potentials for these half cells. So using that information, let's figure out what the voltage is. First thing I need to do is figure out what's getting oxidized and what's getting reduced. So I can do that one of two ways. I just look at these two values. I know the greater one is going to be getting reduced. So in this case, that looks like it's going to be my copper because this value is larger. I could also prove that by getting the oxidation numbers. So zinc is going from 0. Since each chlorine is a -1, this is -1, -1. So zinc must be +2. So it's going from 0 to +2, which means it must be getting oxidized, which is an agreement with what we thought before. Copper chloride, -1, -1, so copper must be +2, going to 0. So clearly, I should label this a little more accurately, the copper is getting reduced. Okay? So with that information, we know because E naught of a cell is equal to E naught of what's getting reduced minus E naught of what's getting oxidized. The reduction potential is for the copper, so 0.34 plus the voltage of what's getting oxidized, -0.76, which I switched the sign, 0.76, which gives me a voltage of 1.10 volts. So that's review. But now let's say we wanted to increase that voltage, or we wanted to decrease it. What would we need to do to make that happen? Or if we made some changes, how could we predict what the voltage will be? So the main thing that we are going to learn about is if we change concentration. So why is this important? Well, remember, standard reduction potentials, the naught up here means standard. That means standard conditions, which for liquids, for solutions, is 1.0 molar at 25 degrees Celsius. So the easiest thing we could change is this concentration. So for example, let's say instead of using 1.0 molar copper chloride, we use 2.0 molar, twice as concentrated. What would happen to the voltage? Or if instead of using 1.0 molar zinc chloride, if I increased its voltage to 2.0 molar, how would that affect the voltage? So in order to do these, what we need to use is Le Chatelier's principle. There is an equation called the Nernst equation, but we don't have to cover that. We're just going to talk about this qualitatively, conceptually. Remember, Le Chatelier's principle is when we have a system at equilibrium and we do something to it. If it gets out of equilibrium, which way is it going to shift to get back to equilibrium? So let's apply that knowledge here. Let's say if the concentration of copper chloride was increased to 2.0 molar, what would happen to the voltage? So just a little refresher, the equation looks like this, plus copper chloride is making zinc chloride plus copper solid. So what have we done? We've doubled the concentration. So the concentration of CuCl2 has increased. So that means the amount of this is now greater than what it was at standard conditions. So we've added extra reactant. So if we think about our equilibrium seesaw, now I have extra stuff on this side. So my seesaw is now going to look like this. So in order to get back to equilibrium, this reaction is going to need to shift to the right. We're going to need to take some of those reactants and turn them into products to get back towards a nice, stable equilibrium. So if this reaction is shifting to the right, what we need to think about, does that mean more Cu is reduced or less, Cu2 plus, or less Cu2 plus is reduced? Well, since Cu2 plus is a reactant, if we're shifting to the right, that means more of the reactants are getting turned into products. So we're going to make more copper solid, meaning more of this is getting reduced. More copper 2 plus is getting reduced. So if more copper is getting reduced, the voltage, the E naught of the cell, will increase. So key point, okay, if we increase the amount of element reduced, then E naught of cell increases. On the other hand, let's try a second problem. If the concentration of copper chloride was decreased to 0.5 molar, what would happen to the voltage? So again, I'm just going to rewrite the equation down below, just for ease. So now we've decreased the concentration. So we have less copper chloride than we did originally. So we think about our equilibrium seesaw, I now have less reactant. I've removed some of this stuff. So that side is now lighter. So this is what my seesaw looks like. So to get back to equilibrium, I'm going to need to shift to the left. I'm going to need to take some of the products and turn them back into reactants to get back to a nice stable seesaw. So since that's happening, that means essentially the reverse reaction is going to be happening to a certain extent, a little bit. So again, ask ourselves that question, is more Cu2 plus reduced or is less? Well, since the reverse reaction is happening, the Cu2 plus is actually getting oxidized. It's going from Cu to Cu2 plus. So since the reverse is happening, okay, the voltage here, the E naught of the cell, would decrease. It would drop below. It will now be less than the 1.10 volts that we said it was originally. So again, this is all a Le Chatelier prediction, determining are we going to be making more of what's getting reduced or less. So let's think about another example. What would you need to do to increase the voltage for the reaction below? So here's a reaction, aluminum, cobalt bromide, cobalt, aluminum bromide. So what I want to think about first is what's getting oxidized, what's getting reduced. Well, aluminum, oxidation number 0. Here, since I have 3 bromines, each one's -1. Aluminum is +3. So aluminum, if we tract it, is getting oxidized. And my good friend cobalt here is going from -1, -1, +2 to 0. So cobalt is getting reduced. So what would I need to do to increase the voltage? So that means I want whatever's getting reduced, I want more of it to get reduced. So I'm going to give you 2 options. You can either change the concentration of cobalt bromide to 2.0 molar or 0.5 molar. Which one are we going to want to do? Well, since we want the voltage to increase, we essentially need whatever is getting reduced, more of it to get reduced. So we want the reaction to shift to the right. So we want my seesaw to look like this. So we got to think about which one of these options would make my seesaw look like this. Well, clearly, increasing the concentration. Remember, we're always comparing it to 1.0. So increasing the concentration, I'm going to have more cobalt bromide, make this seesaw need to shift to the right, so this would cause the voltage to increase. There's something else you could do too. The concentration of aluminum bromide. If we decrease this concentration, so if we made this instead of 1.0, if we made this 0.5 molar, let's think about what the effect that would have on our equilibrium seesaw. Since I'm removing some product, my seesaw is now going to be lighter on my product side. So this is what it's going to look like. That would also shift my reaction to the right, which would increase the voltage.